Here we are given the position of a particle moving along the coordinate line where s is in feet and t is in seconds. So in part A, we want to find the velocity and acceleration functions. So remember, v of t is equal to s prime of t. So that's 3t squared minus 6t. And a of t is the derivative of v of t, which is 6t minus 6. So now we want to find the position, velocity, speed, and acceleration at time equals 1. So s of 1 is 1 minus 3, which is negative 2 feet. That's the position at t equals 1. V of 1 is 3 minus 6, which is negative 3 feet per second. The speed at time equals 1 is the absolute value of v of 1, which is the absolute value of negative 3, which is 3 feet per second. The acceleration at time equals 1 is 6 minus 6, which is 0 feet per second squared. So now in part C, they want us to ask, when is the particle stopped? So we know the particle is stopped when the velocity is equal to 0. So that is when 3t squared minus 6t equals 0. We've created a quadratic equation we can solve by factoring. I'll factor out of 3t, and that leaves t minus 2. So t equals 0 and t equals 2 seconds is when the particle is stopped. So last, in part D, they want us to determine when the particle is speeding up and when it is slowing down. So that means we need to compare the velocity and the acceleration functions. So we're focusing on times greater than 0 only. So this is at t equals 0. And let's say the top can represent v of t, and the bottom can represent a of t. So first we need to figure out the critical values of your velocity and your acceleration functions. So for velocity, it stopped at t equals 0 and t equals 2. And for acceleration, it's equal to 0 when t equals 1. So those are our important values that we need to focus on when determining the signs of velocity and acceleration. So let's say I plug in a number less than 2. Let's plug in 1 for velocity, and I'll get 3 minus 6, which is negative. And if I plug in a number greater than 2 for velocity, I'll get a positive. So now if I plug in a number less than 1 into acceleration, let's say 1/2, I'll get a negative number. If I plug in a number between 1 and 2, let's say 3/2, I get a positive number. And if I plug in a number greater than 2, let's say 3, I get a positive number. So we know that they are speeding up when the signs are the same. So the signs are the same here between 0 and 1 and greater than 2. So we're speeding up for 0 is less than t is less than 1, and for t greater than 2. And we're slowing down in the intervals where the velocity and acceleration have opposite signs, and that's between 1 and 2 seconds.